while Kenji brings up our presentation, Ben hit a lot of the main marks, but I want to make sure to take a moment right now and thank everybody who contributed to this project, everybody who contributed to the Eel Project. I'm so excited to see so many volunteers from the Eel Project on here today. Said hello to a bunch, but Tracy and Lindsay and Kate, it's so great to see you all on the call. This is fantastic. Kenji and I are going to present some work that is really the result of thousands of people, including the volunteers and including our team of authors, which in addition to ourselves include the insurmountable Brian Rahm. Just got to give a round of applause to Brian Rahm, our colleagues Sarah Mount, Jessica Best, Amanda Simmons. So this really, really is a team effort. Now, for some of you, you're going to be like, Bowser, I've seen a lot of this stuff before. Okay, that's fine, but we'll have some new gems in there for you. And for many of you, you may be like, I don't know what they're talking about. There's a lot of words up here. Eels, why should I even care? We're going to try to cover a little bit of something for everybody. So hopefully you'll get some of that. And if you have any questions, we'll have some time for questions, but you can also jot down Kenji's email address or my email address, and we'll be very, very happy to get in touch with you. So let's start it off by figuring out what is it that we're talking about, Kenji? What's our next slide? All right. So in the next 40 minutes, we're going to go over some anguillid eel basics. Oh, there we are with the big words already. We're going to talk about some monitoring data specifically on juvenile eels. We're going to talk about to take that monitoring project and how that is built into a larger framework of community science and how that community science is actually informing eel management along the whole East Coast. And lastly, we're going to talk about some future directions that our research or the Eel Project might be taking. So we've got an ambitious little bit ahead. We'll be bouncing a little bit between Kenji and myself, and we might even ask for a little feedback and questions from time to time. Take it away, Kenji.
Yep. Oh, let's see here. Let's this slide. Okay, so just for context for the rest of the presentation, every good eel presentation needs to start with the life cycle, obviously. So eels are catadromous. So what this essentially means is they start their life in the seas of the Sargasso in the salt water. They live most of their life in the fresh water in their middle years. And if they're lucky, they end their lives in the salt water. But this kind of transition between life stages has a lot of steps in between. So in the Sargasso Sea, they kind of start out as eggs. They transition into this leaf-like leptocephali stage where they float along the Gulf Stream. Then as they hit that transitionary period in between saltwater and freshwater, they hit this glass eel life cycle where they're slightly transparent and small. As they begin to develop pigment, they hit this medium-sized elver stage, and then into their kind of teenage, nearing adult years, they become these yellow eels in the top left. And then once they're ready to head back out into the Sargasso Sea, they become these large, fatty silver eels. And Bowser's got a couple of elvers, which is our kind of pigmented juvenile stage on his screen. But the silver eels are once they're fat and ready to head out to sea and spawn and unfortunately die. But Bowser's going to tell us, why do we even care about eels? What are we talking about? What's the context in the big global scheme?
So a lot of times when we talk about environmental issues, it's good to look at that through a couple of different lenses. And a trio of the lenses that are often used, the sort of triple bottom line, is how do you look at something from an ecological perspective? How do you look at something from an economic perspective? And how do you look at something from a societal, a cultural, personal perspective? And what's interesting about eels is that they really intersect with people, with nature, and with economies in very, very direct ways. So Kenji, on the next slide, we'll actually see just a whole bunch of different pictures. So on the ecological end of things, we got a picture here of a heron choking down quite a large eel. Eels are extremely important within the ecosystem as a food source. For one thing, because they live for a really long time, they're going to intersect at different stages in their life. Those little glass eels, or these little elvers that I was holding up earlier, these are often moving from saltwater into freshwater. They're doing that at a time of year, usually in the late winter or early spring, where there isn't a lot of primary productivity yet started up in the Hudson River. So they are a welcome source of nutrients. And they're kind of a small but mighty transport system of ocean nutrients coming upriver against the current, right? Most nutrients, most sediments, most everything is flowing downhill. Eels represent a little bit of that reverse. So there's that transfer of nutrients that goes back and forth. Societally or culturally, eels are extremely important, not just in the United States, but all over the world. The Haudenosaunee Native American communities of central and northern New York, one of their clans is actually the Eel Clan. I've traveled to other parts of the world. For example, in South Africa, they talk about the Inkanyambu, this beautiful river spirit that is very much associated with waterfalls and with storms, both of which, by the way, are natural phenomenon that are associated with eel migrations. If you go out into the Pacific Islands, you'll find many stories of eels that have to do with the formation of islands, with the founding of coconut trees, with all sorts of things. So many different cultures have long-standing historical connections to eels. And then part of that connection to eels, of course, is that they are delicious to eat. They're a relatively fatty fish. And they're a very delicious fish. Many people who have gone out for sushi and ordered something called unagi, whether you know it or not, you're eating eels. Now, very often, the sort of big three eels worldwide that have been used a lot for food are the American eel, the European eel, and the Japanese eel. But that might change. There's about 19 eel species all over the world. And unfortunately, we do like to eat them, and that is going to have an effect. There is some farming of eels that goes on. There's a picture in the bottom right corner there of an eel farm in northern Morocco called Noun Maroc, where they are capturing those baby glass eels, similar to the elvers that I showed, and over about 2 years, they're growing them up to marketable size. Because of the life cycle of eels, they're actually very hard to keep in captivity and grow from one generation to the next. So almost any eel you eat was caught as a wild animal, very often as a glass eel, and then raised to market size in fish ponds all over the world. But they're supporting a huge multi-billion-dollar industry that has a lot of political ramifications, in fact, that we can get into if we have time a little bit later. But again, and Kenji, you can go to the next slide, the point being that eels are connecting in all these different ways. Now, I kind of hinted at this earlier. The sad news is that eel numbers are down. They are at historically low levels. They are at the basement levels. And this goes across many different eel species. So now this is your time to participate. All of you ecologists out there, put in the chat box, what is the reason why eel numbers are down? And think about all of every environmental course, every environmental project you've ever been on, every conversation you've had. Knowing what you know about eels, their migratory paths, their long lives, the fact that they only spawn once in a long life, the fact that we like to eat them, the fact that they intersect in all of these different food chains and all of these different salinity regimes. What are the reasons in the chat box that eels numbers might be going down? All right, let's see some answers. I got to see some answers. All right. Who's going to put something down first in that chat box? I got to see something. Don't leave me hanging. Barriers to migration. Kate Cooper's got one. Overconsumption plus change in water temperatures, as well as Sandy. You're just going trifecta there. I love it. Interruption of natural migratory waterways. Again, these interrupted connectivities because of dams. Just Tracy going with straight up people. Okay. All right. I love it. We can be a part of the problem and a part of the solution. Here's I guess the great answer, or the horrible answer, is that the real answer is all of the above. Kenji, go to the next slide. If you want to get into this, our friend John Castleman wrote a great article, actually really edited a great book called Eels at the Edge, and it talks about how eels, in a lot of ways, are subject to all of these different pressures. You guys have hit them, and you're absolutely all correct. So on one hand, this makes eels sort of, oh no, threatened from multiple different avenues, but that also, in a way, makes eels a good indicator species. And what I mean by that is that if we as managers can manage an ecosystem, or what it really should say is build a community that is good for eels, it's probably going to be good for a lot of things. So the presence of eels means something somewhere is going right, but the absence or the decline of eels means that something somewhere is going wrong. And in addition to all of these sort of scientific impacts and these cultural impacts and all of these different things that affect eels, there's another thing about eels that we need to be concerned with. Kenji, what's that next slide? And who's going to tell us about that? Well, I'll tell you who. Our good friend Kate Cooper is here representing the fact that perhaps most importantly, many people don't know or care about eels. And this is what my friend John Waldman and Karin Limburg called social enemy, meaning the fact that if you don't know it's there, why would you think it's important? Or if you think something is dangerous or electric or snake-like or gross or slimy, you might think its absence is a good thing. So when we set out in our project way back in the 2000s, really what we were sort of trying to ask and answer is a major question. That major question is, can community science, in other words, can the participation of trained volunteers, whether they be scientists or not, can that community science be used to both understand eel ecology, but also to inspire stewardship and solutions and a positive view of dealing with our environment? You be the judge what the answer is. Now, for much of our discussion, by the way, this is an important thing to lay out. When we talk about counting eels and the eel project, we're really focusing on one of those life stages, and that's the glass eel. That's what's there's actually 3 glass eels in my hand right here. It's hard to see. Look for the little poppy seed eyes. This is that stage of eel that is making that transition from saltwater to freshwater. This is that baby eel that is migrating from the ocean into our coastal rivers and estuaries. So it's a really interesting life stage. It's where it's going from saltwater to freshwater. They're probably close to a year old at that point, but that's when they're traveling often en masse and often in kind of convoluted channels. So you can actually catch and count quite a few of them at a time. The way the Eel Project operates, and this, by the way, is modeled off of monitoring programs of the Atlantic States Marine Fisheries Commission up and down the East Coast. But the way we do our monitoring program is every late winter and spring at a dozen sites along the Hudson River where various tributaries enter the tidal Hudson River. So we're right at that edge of tidal, but not quite tidal. We stake in these funnel-shaped nets called fyke nets. And once we put a net in, every day, warm, hot, chilly, freezing, teams of volunteers go out, open up those nets, take whatever's out of that, in that net out, count up the eels, and then deliberately take those eels upstream, preferably above the next barrier to migration. And we do that for 2 reasons. 1, we don't want to recatch those eels. And 2, following ASMFC protocols, we're actually doing a little mini restoration project. That dam probably hasn't been there historically, so by taking those baby eels and putting them above that dam, we're giving them a little fin up on their journey up into whatever habitat they're going to settle in and hopefully mature for 10 or 20 years. So we do this at a lot of different sites. With a lot of different volunteers, all of whom are trained up with lots of safety protocols, with lots of robust data protocols, which we'll get into in a minute. But this is the basics of the Eel Project. And anybody who's calling or dialing in from the Hudson River area, you too can be a part of this. You might also hear us reference some other forms of sampling, such as an eel mop, like Jisun has here on the left. This is you can also call this an artificial habitat device. It's basically polypropylene line that's been teased apart and connected to a concrete block. You sink that down, and juvenile eels will actually sort of burrow into those floating fibers for shelter. You can take that out, shake it out, and it is a great measurement of either the presence or absence of eels, but also the timing of eels. When do we start to see them? So this is a much easier piece of gear to use that we use as an early warning system for ourselves, and B, that we encourage others to use if they want to start their own kind of eel project. This is an easy way to get involved without investing a lot of time and money into fike nets. Go, Kenji.
Oh, it's still you, Beth.
Oh, great. I mentioned that we have 12 sites. Actually, we probably have more than that. It changes a little bit from year to year, but generally we have sites that start in the south in New York City and Staten Island and make their way up the tidal Hudson River through the brackish area of the Mid-Hudson, all the way up basically to Troy. The furthest north fike net that runs every year is at Hanacroy Creek, just south of Albany. The furthest south that runs every year is in Staten Island in New York City, and with a baker's dozen in between. The other kind of neat thing about this project is that we're not looking at eels from just one site, we're looking at eels along an entire salinity gradient. So that allows statistical nerds like Kenji and I to ask and answer some interesting questions about, well, is every tributary the same? How do eels respond to salinity differences? All sorts of interesting questions this kind of spatial and temporal resolution allows us to ask. That, by the way, is one of the great values of community science. With more with more waders in the stream and more eyeballs on the net, we can collect a lot more data that allows us to ask and answer a lot more questions. Kenji, you take this one.
Okay. So this is kind of our obligatory, after really 14 years, this only goes to 2022. Look at all this data, it's a lot on a slide. I'm obviously not going to talk about it, but look at all this data all of our volunteers have collected over this time. It's a ton of work. Each blip on this is a day of people going out there and collecting for an hour. So we've definitely amassed a good amount of data. So from this point, I'll kind of talk briefly about some descriptive ecological results. Bowser will pop in and talk a little bit about some volunteer results and feedback we've gotten. And then we'll kind of jump straight into this community science eel management framework that we've kind of sussed out of this whole project. So firstly, out of all of those sites Bowser had on the previous slide, we have 6 kind of key primary sites where the collection of data has gone for over 10 years. And initially, kind of at a first look, we have this north-south gradient, which allows us to ask questions about maybe salinity differences and how that might play a role in migration. But really, one of the things you see that pops out is it's not the same signal. If each dot on here is the total kind of catch of that year, the total eels that are caught, you see the signal is highly variable between sites. And this matters a lot if you're going to go, look down the coast of the Atlantic and you only have one site, you're not really getting a representative sample. And so this is really important. It'll kind of come up. I'll describe it more later. But they're highly variable, and kind of initially we're seeing that at least 5 of these sites of the 6, we're seeing an increasing trend in the eel counts. So from a management perspective, 2 kind of key characteristics that we're concerned about is what are our changes in eel ingress from year to year, and what are the key migration durations? So how do we optimally, invest volunteer resources? So initially, if we take all of our sites that we've collected with at least 10 years of data and we normalize and aggregate them, we see this kind of tight upward trend. I will say, as we throw this in there, we do have to caveat that I don't really want people walking away from the presentation being like, awesome, eels are doing great. We are, they're recovering, because here's a little eel trivia. If you remember the beginning of the presentation when we talk about the life cycle, they spawn in the Sargasso Sea. So this is referred to as a random breeding population. It's called panmictic. And so this random breeding population, it starts in the sea and it spreads out along the coast. So really you need to see this increasing trend at all of our sites. Otherwise, this could be the result of something like increasing sea surface temperatures that are just shoveling more eels from the south up north, and we're seeing a result of environmental changes rather than actual recovery. So you need to see the whole population increase to actually say eels are increasing, but the eels that we're seeing in the Hudson are increasing. Now, going back to this idea of migration duration, we want to make sure we're kind of committing a good number of resources in terms of eels over time. So after 84 seasons of sampling, we're kind of seeing that, we're catching most glass eels within this 60-day window. And, the funny thing is, just looking at, figure A and figure B, this 60-day window is not kind of like a number that tells you what you're going to get, more like it's an average of what you're going to get. You can see it's highly variable. Some days they're going to shoot in over the course of half a month. They're going to be like, I'm done migrating. Thanks for the time. And other days they're going to dawdle. They're going to take their time, and you're going to keep seeing eels for over 2 months even. So these are the kind of initial, results of just looking at distributed statistics. But these are the questions we want to ask: is why is this happening? Why are they coming in quickly? Why are they dawdling? Why do they go through certain tributaries in some years and they pick other tributaries in other years? Those are kind of questions we'll ask in the future, but kind of won't dive into in this specific presentation. So I'll let Bowser take over here.
So thanks. The really, when it comes to this community science project, we're trying to collect data, but we're also making sure that there's a great value of this to volunteers. So what about some of our volunteers that we have? We typically have about 800 to 1,000 volunteers a year. Some sites will have many volunteers, and some sites will have sort of a smaller hardcore bunch. Typically high school students are the youngest that we work with, but there is no ceiling. Anybody who feels like they want to get waders on and get out into the stream, we'll take you. We typically from year to year have anywhere from about a quarter to a half of our volunteers are returning from the previous year. The reason that there's such a big turnover is because we have so many students that are involved. But I actually think that having 30 or 50% returning volunteers is a really kind of a sweet spot where you're always going to be getting new energy and new interests, but you're also going to have a steady core of people who are training the next season, who are sharing those stories, who are sharing that expertise. It's kind of a nice blend for a community science project to have that. We do a little bit of sort of host project assessment, and we ask people basically like, all right, what was your knowledge of your local stream, your river before the project, and your knowledge after that? And on average, really what these numbers say here is, I'm surprised that people sort of rate their previous knowledge so low. I'm like, great, that's real humility. You kind of came into this, hey, maybe I don't know my local river, but people consistently report really feeling like they have learned a lot about their stream by doing this project. And that's really important to us. Yes, it's great to learn about eels, and everybody wants to talk about the Sargasso Sea, and that's terrific. But I also think the finer resolution of getting people in their neighborhood stream is really, really, really important. Eels are a great way to connect with the environment on a hyper local level. So I do love that. Typically our volunteer, Sandy, will volunteer for a day a week. Maybe you're the Monday person, or maybe you're the Wednesday person, or maybe you volunteer for 2 or 3 days a week. Rarely does a volunteer going out there every single day, though I know there's a couple people on this call who might fit under that window. No names right now. The other thing that we love to do is we love to collect testimonials from people, and sometimes these are fairly basic things. Like Kenji, this is one of my favorite ones. A high school student saying, "At first, I only did it for extra credit, But then I realized it was really cool. And that sounds like a great throwaway line, right? Haha, that's funny. But there's actually kind of a deeper meaning in there that we'll get to in a minute. What's the next slide, Kenji? This is the other slide that we have of like way too much data to interpret. A few years ago, we asked some great experts at the Carey Institute for Ecosystem Studies to help us study the motivations, particularly of the high school students and young people who were involved in the eel project. And really what all of this boils down to is a pretty simple sentence on the next slide, which is that internal motivators matter more than external motivators. And I'll put this in context. When we first started this eel project, we would walk into a community group, or we would walk into a VFW hall, or we would walk into a high school auditorium, and we would get out there and be like, people, you need to help us save the eels. We have to study the environment. It's going to look good on your transcript. It's going to look good on your resume. And that's all great, but those are very external motivators. After the study, we realized what at least young people, and I'm going to say every people, what they really want to do is spend time outside with their friends doing something fun. And now when we do our recruitment, we lead with that. You should get out in your cool stream neighborhood with your friends or with your social group. Oh, and by the way, you can secondarily also help conserve eels, learn about the environment, get a good transcript, have a nice letter of recommendation. It has absolutely changed the way we do our recruitment, and I think it has really, really resonated with people. And you can see, like, these are just sort of one-lines from a lot of different high school students. But what's really wonderful about this program is that many of these students who volunteer with the project as high school students go on themselves to have careers. Some of those careers actually intersect with eels. This is our good friend Ji-Sun Reiner. She was a high school student down in Westchester County, and just last year called me out of the blue to tell me that she's now an ecology research technician in Massachusetts. And she took it upon herself to consult with me and has now started her own eel project on the island of Nantucket, where she's using those eel maps we looked at earlier to kind of get a quick map of where different eels may be, and eventually start doing the kind of like more quantitatively serious FIKE network. But it's an amazing example of somebody who is using the eel project as a stepping stone on their own science career. And I think that's a really important lesson for practitioners out there. One of the things that we should be doing with all of our science is making them accessible to as many people as possible. Lowering that bar of inclusion. That doesn't mean we have to ram science down people's throat, but what it means is that we should build opportunities so that people can take their first steps and have the tools and comfort and support to take those steps to start their own journey of science. And by the way, although we're always like, we got to build new science, we got to build new science, remember that everybody's going to take that journey a little bit differently. And as a teacher, I really love to see people going into fields of education. And one of those people is on this call right now. I won't put you on the spot, but one of my good friends, Ashana, is now an education outreach coordinator at the Mohawk Preserve, and she has been volunteering with the Eel Project since high school. And again, she has just got some great, you can read her quote here because her words are far, far better than any of the words that I would come up with. And I just really, really love this sense of community science bringing and making science accessible for as many people as possible. The other thing, by the way, I'm just going to point out here, is that Ashana's work also incorporates a lot of artistic themes and a lot of emotional and intellectual therapy into that work as well. And I think that's another great, really interesting component of science meets art meets personal connection. And again, that is a great avenue for community science to take. to kind of have, again, those interlocking circles upon circles upon circles. Kenji, I don't even remember what our next slide is.
This is where we kind of talk about the framework, which is essentially the title of the presentation. But you know, there's a relationship between eels, community science, and management that we've kind of been highlighting through different mechanisms. But as we've kind of been running this project, really, we sort of recognize that there's something unique about eels as a species specifically that helps them kind of perpetuate and strengthen the relationship between eels and community science and management. So we thought we'd kind of try to break that down into a series of points about what it is that makes eels and maybe species in general ideal for a relationship with community science. And so these are the 5 points. These are lessons from what eels have taught us about what makes a species ideal for community science engagement. Quickly, they're a wide habitat range, seasonality and frequency, species-specific year, umbrella species for conservation, and charisma. So Bowser's going to go through the first 3 of these in a little bit more detail, and then we'll talk about what the green dots are after. Bowser, you're muted.
Oh, I know. Oh, I know. One of the great things about eels is this wide habitat range. So, you know, we're talking about this migration of eels from ocean into tributaries. Kenji mentioned that they're panmictic, meaning they sort of have a random assemblage. They're randomly going throughout that range as far as we know. But what that means is that they're also everywhere. You're going to have eels in an urban creek. You're going to have eels in the Gowanus Canal. You're going to have eels in a suburban neighborhood. You're going to have eels in the most rural waterways possible, which means not only do eels have a wide habitat range, but it also means they're very accessible from a wide range of volunteers. This is not some sort of animal that you have to travel a long distance to, or you have to have an entry to a national park, or you're going to need special gear or special permission to see. You know, you can literally walk down to your neighborhood waterfront, and chances are, at the right time of year with the right gear, you're going to find eels. So if you're building your own community science project, think about the accessibility of your phenomenon, your animal, your plant, your whatever. What is its habitat range, and how does that affect who can participate in the project? Another piece of this is the seasonality and the frequency. So a beautiful thing about eels is that that glass eel season, as we talked about, is kind of concentrated into let's call it a 2-month window. So when we're making an ask to volunteers to contribute, we're not asking them for an indefinite period of time or to volunteer forever. We're able to say, hey, we would really like your help from March 1st to May 26th, or whatever the case may be. And basically, you know, 1 day a week for that time period, that's when the project is gonna start, and that's when the project is gonna end. And because eels are relatively predictable and they're relatively common where we're looking for them, it's likely that you're going to see something. Now, 0 is very good data. I understand that, but 0 is boring day after day. So, well, a lot of our volunteers, they are looking forward to that first eel. And so actually seeing what you're supposed to be looking for is not as common in science as you might think it is. So it's great to be able to not guarantee that, but almost guarantee that. And so if you're building your own community science project, think about how discrete is your ask, and how likely is it that your people are going to encounter what you're looking at. And then another piece of this is making sure that your gear is as species specific as possible, or that your methods are as species specific as possible. Very often, IDing stuff can be very time consuming. We're very lucky in our case because our gear is, there's not many things that are swimming against the current in the cold spring months. We also have an exclusion mesh that keeps out fish like this predatory sunfish here, so that when volunteers open up that net, they're not going to find many things other than eels. And the things that they do find are things that obviously are not eels, like little killifish or water bugs or scuds or something like that. So if you're building a project, remember to keep not just your gear, but your protocols. Try to shape them in a way that you're going to take a lot of the guesswork out for your community volunteers. Try to channel down your question, channel down what you're looking at so that you're taking the error out as much as possible. That's really what the species-specific gear does. It just takes the error out.
So for these last two, one of them is that eels are considered an umbrella species. So to define an umbrella species quickly, it's that if you take action to protect this specific species, you result in conservation efforts that benefit and protect other species within the same ecosystem. So I know there's some dam removal practitioners in the call as well, and anyone who's worked in dam removal has heard the word eels, and has heard of eels as a target species for dam removal. Eels are kind of a hot species to target in the Northeast. They're kind of like our salmon in a way. But by targeting eels and trying to, remove a dam that helps migratory fish or to change the waterways to support eels, really what you're doing is supporting multiple different species in that ecosystem. And eels make a great kind of candidate species for community science that allows you to support other lesser known species at the same time. And finally, we have this idea of charisma, which seems a little silly at first. Charisma is like likability. And Bowser kind of hit the key terms a lot of people would use to describe eels, which is ugly, scary, slimy, and gross. That's sad. But what is it about these sad characteristics that make eels so great for community science? Well, it's actually kind of the opposite. It's this idea that there's a lot of potential for change perception. Because eels are so associated with negative aesthetics, the more we can get people out there kind of engaging with them and handling them and being like, oh, you know what? Eels are actually pretty cute. You might even think they're a little cool. You can actually change the perception people have of a specific species. Now, outside of the aesthetics themselves and just kind of the superficial level, this actually has important implications for species because historically, species associated with negative aesthetics are less likely to get support from communities when it comes to conservation efforts. So the more we can kind of shift this perception of an eel's potential charisma, then we can kind of shift the capacity for conservation support for the eel. And, from a grander species perspective, if you have a species that has a lot of potential for increasing charisma, that might make them a good candidate for these community science efforts. And this is kind of where we transition to a different part of that framework, which is what is it about community science that makes eels ideal for management? And we have these last 3 points, which is, again, increased spatial reach, simple protocols, and communication and data transparency. So this might seem a little redundant, but on one end of the spectrum, this increased spatial reach allows a lot of different community science practitioners to get to engage with the eels. But if you look at it from a management perspective, and really if you look at a lot of different eel sampling that's being done across the entire Atlantic coast, as far as I know, there's nowhere that's doing it at the scale that the Hudson Eel Project is doing it in terms of just the raw number of sites that eel sampling is happening. And from a management perspective, we're really curious about, the variability in population we're seeing site to site, or the dynamics between different watershed characteristics that are happening. And so by having this community science kind of mass call to check out eels in these different waterways, we're really increasing our ability to understand what's going on with the population, at least within the Hudson area, until other people kind of adopt this strategy. And then there's the simple protocols. I think one of the things, and often a common criticism of community science, is, can I trust that data? And the nice thing is when you have simple protocols, yeah, you can totally trust that data. I'm just taking eels out of a net and I'm counting them. Doesn't get much more simple than that. I mean, you know, there's the aspects where you're weighing them, and there's a little bit of pigmentation where you have to decide if it's an elver or not. But really, it's the simple protocol where it's like, yes, we can use this. And you know, an example of this is just this last year, maybe 2 years. My timelines are all getting mixed up. The ASMFC accepted the Hudson River Eel Project data as part of their larger Atlantic data set. So clearly, the simple protocols and the reliability of the data are being acknowledged by a larger management agency. So it's working. And I'll let Bowser talk about this last section.
Just the last sort of thing that makes, I think, the Eel Project very successful in terms of both management and education is the idea of communication. When we were working with the Atlantic States Marine Fisheries Commission, one of the things they told us was that we did really well was we put together a really good quality assurance program, basically a document that in just grotesquely minute detail explained what the Eel Project was and what our protocols were. And that B, we had a constant level of communication with our volunteers, communication with the ASMFC. So again, from the point of view, if you are looking to manage a community science project of any scale, think about the systems that you would want to intersect with. And also think about how you can set up communication so that as your program evolves, it's being responsive and responded to up and down those various systems. So you know, that's sort of that's sort of how that worked really well for us. Now, of course, we're not going to stop. So our own future migrations with this project are to keep it going. You know, we're kind of enthused about look at these 10, 12 years of data, but that's really a drop in the bucket for a species that has been around for, you know, tens of millions of years. And so we're going to continue the Eel Project. We're going to continue to collect that glass eel data. We are already looking out at the icy Hudson River and wondering when the first eels are going to show up in our eel mops down south. We'll be letting everybody know. Once the Eel Project starts up, one of the things we're going to look at is within a stream, we kind of set our fight nets up against one bank. And one of the things that we're going to try to look at a couple of sites is across a stream, are eels sort of using the stream the same way? Are they evenly distributed across the stream? Are they hugging the banks because there might be less friction there from the current? Or does that change over time, either season or day to day? So we're going to be taking a look at sort of the stream profile and where and how eels are using various parts of that stream. And that might help inform us what how to sort of calculate how many eels are using a stream or what our index is. We're also going to take a deeper look, now that we have all this data, on our eels and how they respond to different environmental variables. And anybody who's been a part of the Eel Project knows two of the things that we often take a look at is we look at lunar cycle and we look at temperature, and I'll also say we look at salinity. So we're going to take a closer look at that. Is there a relationship between, for example, eels in the river and tributary temperatures? Is there a relationship between when eels come into the Hudson River and what's going on in the larger Gulf Stream or the New York Bight, the sort of coastal areas? So we're going to be looking for that, and part of that is so that we can do a better job of predicting when and where eels are going to be, and also can we track changes over time? Do we see consistent trends in these relationships with temperature and salinity and lunar cycles? And we're really, really happy because we've also gotten really great cooperative data sharing relationships with other states and their own glass eel sampling. We've mentioned the Atlantic States Marine Fisheries Commission a couple of times. Every state from Florida to Maine has an eel monitoring station. Now, most of the states only have one. One of the lovely things about the Hudson River Eel Project is that we have 12 along the Hudson River or more. But we've gotten really great cooperation in data sharing, and we're going to start to take a look at, hey, do trends in other states match or differ from our own trends? Do we see any trends over time or over space across the last decade or so? So that's also going to stay tuned. that's going to be a really fun direction that we start to look at. And then, even though it's not really represented here, the truth is there's this idea of community science, this idea of engaging people in their own environmental research is really gaining a lot of traction, including with people on this call. I was recently was privileged to be in southern India, and I met with some fishery scientists there who were absolutely crazy about the idea of doing some community science to look at several species of anguillid eels that are very poorly understood in the tropical areas, not just of India, but all across the Indian Ocean. So there's a really sort of cool direction to take with this, and again to kind of both collect the good data, but just as important, build that constituency of people who don't see eels as gross or ugly or something to be ignored, but who see them as something to be valued for their intrinsic role in their environment and for something that can be a stepping stone to their own personal growth and their own connection with their waterways and biodiversity. And I believe, Kenji, what's the next slide? This is kind of our closeout slide here. We'll turn it over for questions. But one of the things, as sappy as it may be, is we try to make sure that part of the Eel Project is about love, is about building that personal relationship with your waterway, with your animals, and with your friends. So if you haven't yet, come out and join us this spring. It's on its way. Remember, as cold as it is, somewhere out in the ocean right now, these little eels are on their way to us.